Okay, I think we can start. Please take a seat. I'm going to start. We're already 5 minutes late. So, welcome to Kubernetes and the 12-factor cloud applications. Firstly, I would like to introduce myself. I'm Anna. I'm technical lead at IBM, but basically I'm a custom application development enthusiast and a fearless helper on subjects involving Java frameworks and IBM Cloud. In my spare time, I'm also sharing my experiences within the Bucharest Software Craftsmanship community, which I co-founded together with Victor Renta. In today's talk, I'm going to share with you how Kubernetes complements the 12-factor methodology for the cloud applications. And firstly, why 12 factors and Kubernetes? Firstly, because, when we're starting a project or when we are landed on a project, we all the time think to the evolution of that project. Regardless if it already has started or not, we're all the time thinking how it's going to evolve in time. And Kubernetes, for example, employs declarative formats in order to support the setup of our project. And also, declarative formats are encouraged by the 12-factor methodology in order to set up our automation. Secondly, we want to run everything at push of a button, so we don't want to have manual labor in terms of running our application. So we want to scale up with minimal changes in terms of tooling, architecture, and development process. Thirdly, we would like to have our application portable, and if possible, portable across multiple cloud providers. And Kubernetes is nowadays present in many cloud providers. And it is also helping us to have a clean contract between the application code and the infrastructure on which we're going to deploy our application. And last but not least, we want to have less differences between local and production so that we can achieve continuous deployment. And let's start a bit about our scenario of today. So in the scenario today, we're going to talk about the Dream Home application. That is deployed in a Kubernetes cluster and consists of a Dream Home app, which is an Node.js-based app following the backend for frontend pattern that gets its data from the backend microservices, broker, and property. And these two microservices are the only ones that connect to the database, the cloud and database instance that stays outside of the Kubernetes cluster as a managed service. For logging, I will use an IBM Log Analyze managed service. And of course, everything is containerized, and the Docker images are stored in a private container image registry in the IBM Cloud. So let's start with the first factor, with the code base. Well, the first factor tells us that we should have one code base in revision control from which we spawn multiple deployments. However, in the previous scenario, we have seen that there's not about one application, there are 3 applications. In the case of multiple applications, the best practice is to follow the 12-factor methodology for each application by its own. So each application that I described earlier will have multiple deployments. For each multiple deployments in Kubernetes means having a namespace dedicated for that deployment. And how can you achieve multiple deployments in Kubernetes by not changing anything in your application code? Well, by employing Helm, the Kubernetes package manager. So for Helm, you are using a set of templates, the Helm charts. And nothing changes in your application code. The only thing that changes across environments is the namespace and the values that you're using for deployment. Those being said, let's go. Sorry. Let's go into the code. Okay, come on. I'm a little bit nervous. So we're going to go and deploy our first. Wait. Too big, I think. Oh. 1 sec. We're going to deploy our first microservice, the broker microservice, with Helm charts. Firstly, let me just check that everything's OK with Helm, issuing Helm version. So the clients are fine. The server, the tiller that is in my IBM cloud cluster is responding to me, so we can go ahead and create the charts and deploy them. And creating the charts means Helm create broker, let's say. Going to the IDE, I'm just going to edit the templates for our deployment. And the first one that I want to edit is the description of what I'm going to deploy. By default, Helm is generating some information for me, but I will just delete some and replace it with something relevant for my deployment. And of course, some information for the values that I'm going to use in my deployment. And for the interest of time, I'm going to use some predefined values that I am having so that we can smoothly deploy this application, which consists of the following. The first part of the values is related to the deployment object of Kubernetes and is about what image I'm going to deploy, the image tag that I'm going to use, some environment variables that I need to in order to have a successful deployment, the secret that I'm going to use in order to connect to the database, and of course the service part, I mean how I'm going to access my deployment. Those being said, let's go to the templates part. In the parts of the templates, for the deployment template, there are already generated a few things. We're going to keep the first part of the deployment template regarding the API version, the kind, deployment, of course, a part about labels, specifications, and we're just going to change the part related to the specifications of our deployment object, the one that we have here as value, so only the part related to the containers. So I'm going to just go like this and replace it with my own. So for the first part, I replaced everything. Also, the secret for which I'm going to pull my image is going to be there. The name of my container, the image, the port, and everything else. Now, everything that's down here as a value is replicated upstairs as in the template through its name. And those being said, let's move a little bit to the environment. And I see here that I have also a config map defined. So this means that when I'm deploying my application, I expect that a config map object will be present there. However, when I'm looking in the templates, this is not present. And nothing stops us into creating actually a config map. So I'm going to create a config map template. The name is going to be, let's just take it like this. Name is going to be the one from here. So, the deployment, the namespace, let's say dev for the deployment, because I'm going to deploy it on dev. The port that I will need is the one from, let's just say values. Okay, 1 sec. Values.service.port.node port. Okay. Just let me look a little bit on this one. Service ports, it was plural. Okay, and the mount path is going to be the one that I specified here also. My config map, it serves on the purpose of exposing some values of this deployment for the front-end deployment later on. And after doing this, let's just take care also about the service. And we're going to keep also the first part because it's auto-generated and doesn't affect me at all. The only thing that I'm going to change is this part of the specification about the service. And it's going to go like this. Well, service type and ports and everything are just going to be acquired from the values. Those being said, we're going to issue the command from the slide for deploying this with Helm. So Helm install my charts called broker with the name, let's say broker minus Helm, within the namespace dev. And let's just issue also debug to see what is going on upon installing the charts. Okay, so the containers are created. Let's just check the status of our recent release broker minus helm. Okay, so the application is running. And one more thing, because I don't remember the port, so 31250. Just go to the browser and access it directly. Oh, sorry. Too fast. 31250. And access it directly through the cluster IP, which is publicly available. So the deployment was successful only by issuing one command. The only thing that's going to change across each namespace are going to be the namespace name and probably the values that I am going to provide. So typically when you're using Helm, you have values.dev, values.qa, and so on. Now, let's go a little bit to the second factor. The second factor talks about dependencies and isolating dependencies in a specific file. So from the application point of view, you're isolating dependencies in Node.js at the level of package.json, in Java at the level of pom.xml. Now looking a little bit above at the cluster level, Kubernetes level, in order to access a deployment that you have done only at the deployment object, you need a service. A service in Kubernetes is defining the logical set of pods that is targeting in order to access, but also a policy through which those are accessed. And that policy is being specified, let's say, by labels. And those being said, let's go to the part of deploying the second microservice, the one that is related to property, and see how the labels are connected in order for the service to look over the deployment done. Okay. Just move a little bit above. Okay. And this one is going to be deployed using the regular manifest file of Kubernetes. So actually, let me the property one, and then we're gonna issue the deployment part, which is the name of what we're going to deploy is property. The tire is backend. All these labels here are done by me. So app is property, tire, backend, implementation, and you can add as many as you want. That is micro profile for property. The secret, reg secret, so that I can pull my image. I see that I have another config map to define, so I will use this one to define a config map for myself to expose my things, and then a node port to access my future deployed application. And going to the config map part, I'm going to create this one first, and then dev 31246. And the mount path opt service minus bind. Let's deploy firstly the config map. kubectl apply minus f config map yml minus namespace dev. And then apply the deployment.yml. Okay, so what you can see here in the deployment part is that first part is regarding a deployment object. It has some labels specified, and the second part is about the service also having labels, and the label selector is looking for the application property. So this is how they're going to find each other by after the deployment. Then they're deployed together. Let's check also the application, the port 31246. So 31246. Okay. So this has got deployed, just got deployed, and I have just one property listed for the moment in my database. Those being said, this is how we're managing the dependencies from Kubernetes point of view through labels. The third factor is about configuration and storing configuration in the environment. And the thing is that in Kubernetes, the configuration is being stored in two ways in the environment. One is about creating secrets, and the other one is by creating config maps. And you have seen earlier how I've created the config map. The other way around is by creating directly a secret. So all the time, I'm going to look over my managed services by looking for the secret binding cloud-agnostic, which contains the data that I need in order to connect to my database. Or if I need to pull an image from the container registry, I am going to use the reg secret, and this is how I can pull the images. And this is how you create a secret, or a Docker registry secret, in order to pull your images. This is the cleanest way that you can use in order to store configuration in the environment. Let's deploy the broker microservice the standard way and see how it uses the secrets part. So we're going to go a little bit back. Broker. And look into the deployment. So for the deployment, the same as the other part, the name broker for the application deployed, entire backend. But this one has the implementation Spring Boot. The image pool secrets is my reg secret that is present in my environment that I can look for by issuing kubectl get secret ---- namespace dev. You can see here. Then the mount path, the volume mounting, and of course the port to which I'm going to deploy. And simply just apply again the broker deployment file. Cool. Just check if everything went well. 3, 1, 2, 4, 8. Cool. So far, there are two parts of our application deployed in the cloud. Let's look at the fourth factor. Well, the fourth factor of the 12-factor methodology is instructing us that we should regard the attached resources as services as attached resources to our application. So, for example, the broker and the property microservices are regarded as backing services for the Dream Home application, and the managed services the managed services cloud, the managed services, the database and the database and is considered a backing service for the broker and the property microservice, while the container registry is actually the backing service of our deployments that are happening in Kubernetes. Those being said, there is no difference for a 12-factor application between local, let's say local in the Kubernetes cluster, or actually the Kubernetes worker node, and a third-party managed service. And for treating backing services attached resources, in case of the third-party services, I've just used an IBM Cloud command to bind my service to a specific namespace in order to furthermore make use of it. But for the next deployment, we're going to just look how the front-end application is binding itself to the backing microservices. And those being said, let's move a little bit upward. This one. Dream Home BFF. Just going to deploy it like this. For the tire has changed. Now it's front-end and the implementation is different. And here for configuring the environment part, just for the backing services, the first one that I'm looking for is the broker. It doesn't matter the order, it just matters the name. Wait. Sorry. Okay, and the second one is property. Okay. And all my configurations for the last application are going to be retrieved from the config maps. And I need also a port to expose it. consumption. And firstly, before actually accessing the deployment, just check that my config maps are defined. So get config map -- namespace dev. So both config maps exist. Let's go a little bit above and install and apply the deployment -- Cool. And if you remember from the second factor, we had only one property. So my expectation is that I will see only one property here after the deployment. So yeah, that's just one property. So basic, simple application for adding a property, editing or deleting it. Cool. Let's look a little bit at the factor 5. So far, the first four factors were more about manual work, and we want to automate this. And in order to make it more automatic, we're using pipelines. So all the time, we are going to build and run our application in a repetitive way. And what happens there is that for the build stage, our application code is going to be built using the Docker file definition. An unsuccessful Docker image build, we are pushing that image to the container registry, and as a result, we have a valid artifact ready to be run. However, before just going into running the application, it is advisable to have a stage in between building and running that application so that you can check that your environment is ready to receive that deployment. And the release stage normally is used for validation of, let's say, I'm just going to show you how a release stage script looks like. Is used to check that, let's say, the cluster is available, is up and running, and the workers are there and are ready to run your application. Then, if the namespace is available, if maybe the namespace is not available, you can create it on the spot. Also, if the private image registry, in my case, reg secret, is there present. If not, maybe that image registry, secret can be created. And also, last but not least, you can check if you're using Helm, you can check that the tiller is working for you. So if the tiller is not working, you might end up not actually deploying anything. The existence of such a stage is stopping you from trying to deploy an application and getting to an unsuccessful run or actually no deploy. So it's good to have a way to stop and then just revisit what you have done in the configuration of your environment, or maybe you can just catch up and rebuild on that configuration. And last but not least, after the successful release stage being run, you have the run stage, where you can, for example, if you're using Helm, in my case, you are just using Helm charts, you're installing or you're upgrading a certain release, and ta-dam, you have a successful run stage. This is why it's so important to have just a stage in between. So some of you might think that it takes a longer time to have an application up and running. However, it's better to be safe than sorry. And is actually much, much better to know where the problem came from than just inspecting all the time what happened at the runtime and why our deployment didn't work. That was quite a run. So the next factors are actually more about the performance. The sixth factor is talking about the fact that an 12-factor cloud application is an application that is regarded as a stateless, as an application consisting of stateless processes. So what this means that if we need to persist anything within our application, we should persist it, let's say, in a database. This is why we have the cloud database binded to our backend microservices. But from Kubernetes' point of view, you can store information in three ways. One is it at the container file system level, and the lifetime of storing something in the container is as long as that container lives. The second one is storing information at volume level, and at volume level, that information is going to live as long as the pod lives, and we're going to talk about the pod lifecycle in a minute. And last but not least, the most actually the best way to persist data, if you're thinking of Kubernetes, is the persistent volume. The persistent volume has the lifetime of the cluster. So once you created a persistent volume, that's available at cluster level. And you can use that from every namespace that you're having. So we're going to have a little scenario now. We're going to create a persistent volume. And we are going to create, furthermore, we want to copy some scripts in that persistent volume. So from each namespace that we're having, to use those scripts on demand. In order to copy scripts to persistent volume, we need an additional pod, an intermediary pod, through which we're going to copy our scripts over there. So let's do this together. Let me just close all these. Okay. So the first one is about creating a volume. So creating a persistent volume in Kubernetes means that you are going to create a kind of object called persistent volume. You just give it a name, let's say shared persistent volume 1. Make sure that you label it accordingly, shared volume, and down shared volume. A persistent volume became policy is needed in order to access it. And of course, the access mode would be read, write, many, because the same persistent volume, being at the cluster level, can be accessed from many namespaces. And we would like to read and write in that for many times. However, just in the case of the deployment objects, working with persistent volumes means that you need a policy to access that persistent volume. So this is why at each namespace that you're having, you have a persistent volume claim. The persistent volume claim that you are going to put in place is going to be the one that's going to give entrance for our pods to access the information from each namespace. And of course, it's matching the labels of our persistent volume here. Let's deploy this one. Wait, to dev. 12-factor property. And create a volume. kubectl apply -f create volume minus namespace dev. This one takes a little bit longer. The creation of the volume is more. So now we have a persistent volume and a persistent volume claim to which to access it at the from the dev namespace. And we want to copy some of our scripts to that. We're going to create an additional pod with the copy scripts deployment part. Just check like this. Now, my copy scripts deployment is going to be of kind job. It can be also of kind pod. But I want to do something additional with it. I want to check that my files are copied over there. And in order to do that, I'm going to just all the time issue a command and see if something was copied was copied over there. If nothing was copied, the pod will continue to interrogate the location. When something is found, then it's fine. This job has ended. And we're just going to call it copy scripts polar. The PVC, the persistent volume claim name is going to be shared PVC dev, and this is the one that's going to be mounted to this pod. The volume name, let's just say shared volume for the sake of it, and yeah, it's going to be mounted here. And of course, running a small image of Alpine Linux and checking if something was copied in the shared Dream Home scripts part. If nothing was copied, to wait for the scripts to be copied. When the scripts are copied, then just list the scripts that are over there. Let's apply also this deployment. kubectl apply -f copy scripts YAML -- namespace dev. And let's check its logs. So firstly, let's check if the pod got created. This -namespace dev. Cool. Let's inspect its logs. kubectl logs. Okay. What? Oh, yes, I forgot the namespace. So the scripts are waiting to be copied. Now I can copy my scripts by issuing let's just do this, kubectl copy. Everything that I have in my folder scripts to the pod defined above, and in the location shared dream home minus scripts, minus namespace dev. It's going to be difficult to be read. I think it's enough. Okay, and now I'm just going to check the logs of the pod again to see if the scripts were copied. Yep, so my scripts are copied in the persistent volume. And if I'm going to look at my recently run job, that one is completed. So kubectl get pods minus namespace dev. Yep, the poller is done. It's not going to work anymore, and has done its job at acting as intermediary for copying the scripts. And furthermore, I want to use those scripts, and this is why I have a new scripts deployment that's going to run the script 1 for myself. So let's just go and apply it. -f use scripts minus namespace dev. And just to see how the running work, we're going to look in the logs of the pod associated with use scripts. Minus namespace dev. Just copy it. And just kubectl logs. This one, minus namespace dev. That's hello from script 1. This was the contents of script1.shell script. So it was echoing this one. Those being said, this kind of scenario helps you with running same scripts across namespaces as processes in Kubernetes. The factor 7 is related to port binding and the fact that our services should be exported by port binding. What happens in case of a deployment, as we have done before, is that a deployment object gets created. Based on the specification of the deployment object, replica sets are being created. And the replica sets template dictate how many pods are going to exist associated to our deployment. Furthermore, we have a running application, but we need to access that application. And we have the service for that. And for service, either we define it in YAML, as we have done so far, either we can use the kubectl expose command in order to expose our deployment. However, the kubectl expose command can also be used for proxying existing services. So for example, if you don't want to expose directly an application that you're having up and running through a service, and you just want to conceive a bit of it, but and give the furthermore access only to some other services, you can use the expose command for proxying that. And we're just going to go and proxy one of the existing services that we're having. kubectl get services minus namespace dev. So we can proxy their dream home BFF. kubectl expose service dream home BFF. With the type, it's going to be still node port because I want to show you that it works. Type node port. For the service, the name, it's going to be dream home proxy. And namespace. This is good. Namespace dev. And now let's check the port of the recently created service. So the DreamHub proxy, right, on 3107. Just go here. And it's the same application as the one deployed earlier. So just proxying this one, it gives us access to the same deployment that the DreamHome BFF service was giving earlier. The eighth factor is about concurrency. So when we're applying a YAML file, what happens is that a deployment object gets created. Having, and its important parts are a selector, a template, and the amount of replicas that need to be created. The selector is always going to be the way that the replica set know to which deployment can be binded. So these two have to always be the same. If something changes regarding the selector of replica set, because replica sets can also be deployed independently, there's going to be a rupture between the deployment and the replica sets. Furthermore, so they won't know to which deployment they belong to. The template of a replica set is going to follow the pod template, and the spec replicas are going to be the same as the replicas in the deployment template. Based on the template, an amount of pods are going to be created. So far, we have worked with deployments that created only one replica for each of our applications. And in terms of scaling, when workload for our application is increasing, we want to be able to scale out via the process model. So we don't want to apply all the time the deployment in Kubernetes. We want just to gracefully scale and let Kubernetes do its work. And that's being done in Kubernetes by setting up an autoscale policy, by issuing kubectl autoscale deployment name, setting up a minimum amount of pods and a maximum amount of pods. And this autoscale policy has this option of CPU %. So a pod is being added to an existing deployment when the CPU % here is being reached. If this is not mentioned when setting up an autoscaling policy, there is a default autoscaling policy in place, but you'll have unpredictable behavior of your deployment. So do not forget about this one. And of course, the namespace to which you are applying the autoscaling policy. There might be a small difference in terms of autoscaling across environments based on the power of those namespaces that you're using. And let me autoscale one of our deployments just to show you how it works. kubectl get deployment -- namespace dev. We're going to scale the broker. kubectl autoscale deployment broker -mint amount of pods set to 2, maximum to 5. Let's say -CPU % set to 70%, and the namespace, of course, dev. So now that the deployment was, the autoscaling policy was set in place, my expectation is that for the broker deployment to see 2 pods associated to it. So yeah, you can see here that another pod is being created, and the status is container creating for the broker deployment. And every time the workload for my deployment is going to reach 70%, another pod is going to be set up. Factor 9 is talking about disposability. When we are working with an application and we are deploying an application repeatedly, we want to have 0 downtime, right? So we want to be able to have a graceful shutdown of what was before and to be able to start up that one very, very fast. If you're using Helm for upgrading a release in each namespace, you can issue the command with -- recreate pods, which is going to restart your pods upon applying that chart and issuing that release. So this is one way that you can achieve the zero downtime with Helm, and also to restart and make sure that you're restarting your pods upon applying that release. And also in terms of disposability, if you're having, let's say, replica sets that are orphan in your Kubernetes cluster, you can use kubectl delete replica set. Or if you have namespaces, like you have tried a few things in the beginning in the dev environment, and you just want to make sure that you don't have anything left over there, and you're just collecting any garbage, you can use the helm delete -- purge release name. The helm delete -- purge release name command is very powerful. It's going to erase not only your pods and everything associated to that deployment or that release, but is going to just wipe everything from the history of Helm about the release you have done. So that one should be used with care and like one time. And also do not try to give a very generic name for the release name, because you might end up with deleting a lot of things. Now, the last factors are about something that interests us, the developers, and is about having dev-prod parity. When applying, when we're working, we want for our changes to be propagated as fast as possible across namespaces. So we want to make sure that the time, tools, and people gap are maintained as small as possible. Why? Because in order to have a short amount of time of propagating changes between dev, staging, and prod, there should be existing a set of policies that do not imply some people to approve those changes in order to be propagated, or some people to use tools in order to approve those changes. So keeping this gap as small as possible is one of the goals to have when doing continuous deployment. Also, from Kubernetes' point of view, keeping the namespaces as similar as possible is by not only creating the namespace with a very, very significant name, but also by making sure that the configurations that you're using at the level of each namespace are named the same. The contents of a secret of a config map can vary across namespaces, because there are going to be variations in terms of configurations, inner configurations across deployments in terms of values. But the naming should be consistent. And those being said, I have a script for the environment parity. So when I'm going to use this script, my expectation is that I'm going to create a new namespace that's going to have a secret for binding to the Cloud database, and is going to have a secret in order to access the registry secret. So it's going to have the same parity as I used to have in dev. So moving a little bit further, just cube broker. Okay. Just firstly gonna get my managed service that I want to service bind to the new namespace. Okay. I need its UID to bind it. IBM Cloud Service show cloud-ant -- UID. And using this one, I'm just gonna do this. My cluster name is DreamHome. Name of my namespace QA, and of course this. And you're going to see that firstly, the namespace QA is created. The service with the GUID obtained earlier is being binded to the cluster namespace that I've recently created, and there's a result for that one. And also there's a Docker image registry secret that's going to be created at the end of running this script. So if I'm just going to go and check the amount of secrets that I have for this new namespace, get secrets minus minus namespace QA. You can see here that I already have the direct secret, the binding cloud on secret, and I can later on use successfully my new QA namespace. And all of this just by having a simple shell script. The factor 10 is about logging. Well, logging when we're working in local is very easy for us to manipulate because we're logging to a file and we're finding that one because this work is on our file disk. However, when an application gets deployed in Kubernetes, logging is being done in a specific directory called /var/log, and this directory exists at pod level. However, because pods have a specific life cycle and they can die at a certain point in time, meaning when a new deployment is being done, they cannot exist anymore. You can end up losing those logs that are stored at the pod level. In order to have a good monitoring of the applications that you're having deployed in a Kubernetes cluster, what you can do there is to create additional pods that are never going to be affected by the deployment of your application, to which you can stream the contents of /var/log. And this means these additional pods, there are 3 patterns in the Kubernetes documentation that you can use. Or, as in my case, use a managed service, because this managed service has a beautiful UI, and I can search and do a lot of things in it. And stream the contents of /var/log to the managed service. What this means is that what I'm doing is that I'm creating a secret so that I can bind myself to the managed service. And then after binding myself to that managed service, I can stream the contents of /var/log that I have inside my cluster by getting the definition of a daemon set from that location. And that daemon set is attaching to the worker node that I have, and is going to stream the contents of every pod I have in each namespace. If a new deployment gets applied, this daemon set is going to be so powerful that it's going to just attach to that one, to the new created deployment, and it's going to stream again the /var/log to the managed service. And just to show you how this works, kubectl get pods. I'm just going to find the logDNA agent pod. And looking at its contents, kubectl logs. Okay. So you can see here is that if something is not existing, is not copying, is not tailed anymore. But since our work started and our deployment started, you see that there's for each deployment a new file gets added, or for each new pod created a new file is added. And what happens is that the daemon set is taking that file from /var/log to the exterior, and the amount of files that exist copied to the managed service increases in time. And then if you look in the interface, everything is being logged here. Yes, I know it's everything. It's a little bit messy. But you can search, you can do a lot of cool stuff in it. So it's much more easier for a developer to inspect logs like this than just going to the pod and issue kubectl logs, or actually going to the Kubernetes dashboard and look in the logs of that pod. The factor 12 is about that admin processes should be running as one-off tasks. A sample of admin processes represent, like, I don't know, when you are spawning a new environment, you need to initialize a database. That's a one-off process, so you don't initialize a database all the time. But for initializing or for running certain scripts, you've seen earlier at factor 6, you can persist those scripts in a persistent volume and then later on run them. That type of behavior is being encouraged when you have multiple scripts that need to be run. However, if your scripts are small, you can also copy your scripts in a config map and run them from that config map using a Kubernetes job. So this is what we're going to do now. We are going to, firstly, let me check where I am. Yeah. I'm a broker. Broker property. And I'm going to create a config map, dream home config, let's say, with the contents of my scripts folder. And I'm going to say from file, just give the name of the entire folder, to the namespace dev. And I want to see the contents of that config file as a YAML. So yeah, I can see here that my config map was created containing as data the script 1. It has an echo, and script 2 another echo of a message. Pretty simple. And I can use this because my scripts are very, very small, so I don't need to copy them in a persistent volume. And this is another way of running scripts by just copying them in a config map as data. Furthermore, I want to use these scripts in a one-time job. So I am going to create so-called batch job that I'm running one time on admin tasks. So my dream home admin task is going to run in parallel 1 to completion 1. This is because I want to make sure that my task is being run only for one pod till the completion one time. I want to be on one-off process, right? And is making use of scripts that are mapped into the volume and into a volume called Dream Home Scripts volume that I'm mounting to my job, and the data that I need in order to run my scripts is being located in the config map with name Dream Home Config. Those being said, I need to execute my script 2, let's say. I'm just going to give a small command for this one. And I think we're ready to apply the deployment for this one. kubectl apply -f. Let's say batch .yaml -- namespace dev. Let's get the what has run here. kubectl get pod -- namespace dev. It's going to be Dream Home Admin. kubectl logs -- namespace dev. It says hello from script 2. So my script 2 was run successfully by using this job. Some takeaways from the presentation. Decouple infrastructure complexity from your application code. As you have seen here today, I haven't worked anything at the application code level because everything is in the Kubernetes manifest files. So I'm just playing with those. I'm never touching my application code. So there's a decoupling happening between what I am issuing to Kubernetes and my application code. They can work independently to a certain point. Also, please take a look about the persistency and the services that you're using for persistency. So you can have managed services, and for that one, some people don't like managed services because it binds them to a certain cloud provider. However, it spares you for a lot of things to be done regarding maintaining them. There is another possibility to use services deployed directly in your Kubernetes cluster, and those normally are attached in the persistent volumes. However, if you're using services in the Kubernetes cluster, you need to manage those and yourself. You're the one that you have deployed. Also, keep the environments as similar as possible so that you can have an easy debug of what you're doing. Think of your application as stateless because your pod has a certain life cycle and it can die at some point in time. Scale your application using auto-scaling policies and use appropriate logging in your application code and also at the cluster level logging. So one thing to be told about logging, try to avoid system.out in these kind of applications and use an appropriate logger for each of your applications so that you can catch the right message either in the managed service or wherever you are applying the cluster level logging. And last but not least, the strongest factor for the 12-factor methodology is yourselves. It's quite challenging to apply the 12-factor methodology and also to think how this would work in a decoupled way with Kubernetes. But always, always try again. So if you think that you have failed once, try again. Believe that you deserve to be successful when applying both Kubernetes configurations and 12 factors. Thank you very much for listening to me. I know it was quite a run. If you have any question, I don't know what's the time before our next speaker comes. I think he's going to come. But you can catch me up around here or after the presentation and ask me more. I know it was quite a run. Maybe I missed something. Thanks.